Alright, so guys, when we look at the Earth, I think it's really important that we truly understand that the Earth is a dynamic place, which means it's changing all the time. With that change, it's kind of important to understand that we don't necessarily see the change until it's significant. And the way I'd like to kind of best describe that, it's like basically the story of the frog and the hot pan. You can actually boil a frog alive.
No.
I don't suggest you do that. That's inhumane. But you can do it. But it's not like boiling a lobster where you literally take the lobster and throw it in a boiling pot of water and we're happy. Which, by the way, has anybody ever done that?
Actually, like,
Boiled a live lobster.
And then they eat it?
Yeah, they're not very happy. And you can actually hear it.
that's all right.
Yeah, it's very hard to do. Now, the reason why, like I said, another reason why I bring this up is because with the frog, you take the frog, you throw it in a boiling pot of water, guess what the frog's going to do? Nope.
They'll be fine.
The frog actually,
Prince.
no, yes, sure.
I'm
No, I should sleep at night.
It's going
Basically, the frog will jump out of the pot. It's hot water. Same thing you would do. If you fell in boiling hot water, you get out as fast as you can.
I feel great.
However, you take that same frog and put him in the pot, and then turn the stove on, and the frog will literally boil itself.
That's all.
And it's because it's at such a slow rate, the frog does not realize the water is getting hot until it's too late. So a lot of times when we look at the changes that are occurring on Earth, they occur at such a slow stage. And the reason is, our lifetime at maximum in most times is about 100 years. There are some people who can live longer, but basically we're looking on average between 60 and 70 years for a human lifetime. Well guys, that's 60 or 70 years out of 4.5 billion years. Our existence on Earth is ridiculous in terms of the total change that Earth goes through. And when Earth changes, it changes on a very slow scale. So I think it's important that we don't really appreciate those types of things that are taking place. So I thought today when we're talking about chemical reactions, and we understand some basics things that we might have forgotten. So one of the first things I want to talk about today is pH. So what does pH actually measure? Acidity, right? On one side we have extremely acidic values, okay? And on the other we have basic. So you have your bases over here, and we have acids over here. Now your acids are basically going to be between 0 and 7. And your bases are between 7 and 14. And what's important to note with that, and don't worry about writing all that down, we're going to go over that later on today. It's one of the things that we have set up for us to do today. Is I want to make sure we understand chemically the difference between an acid and a base. With a base, it has the hydroxide ion attached to it, the OH negative. And it's called a hydroxide ion. And those are your bases. With an acid, it has the H+, which is your hydrogen ion. So again, your bases are going to be between 7 and 14. And your acids are between 0 and 7, with 7 being neutral. It's basically pure water. So if we think about distilled water, that's going to be a pH of 7. Are we clear on that? All right, so we're going to do a little lab for a moment. So, as you guys went around, we looked at all the different samples. What did you notice about the cleaners? Most of your cleaners, what did you notice about the pH level of the cleaners? The floor cleaner, the all-purpose cleaner, the window cleaner. Why are they dangerous? Well, on what side of the scale were they?
Right.
Should have been on the basic side. They should have been had a high pH level. Okay, so the higher the pH level, the more basic it was. And so when we look at this, this is basically what we should have had. We should have had a lot of our cleaners are going to be on the basic side. All right, so so what does that tell you? What's one of the main ingredients in your cleaners? What type of ions?
31.
What's the main ion that's part of bases? Hydroxide. Alright, so it's going to have, so a lot of your household cleaners are going to have that OH negative ion, and it's because of that that allows them to actually be good cleaners. Now, the one exception to that was what? The toilet cleaner, which was on the complete opposite end of that spectrum, all the way down here at 1. And here's what's interesting. If I take my hydroxide ion, OH negative, and I add it to my hydrogen ion from acids, what substance do I get? Well, if I take OH negative and add to H positive, what do I get?
Water.
Okay, H2O, you get water. So what's important about that is a lot of times to neutralize your acids, you want to add bases to them and vice versa. If I have a very strong base that has spilled, what I need to do is I need to go find an acid that has the same effect but on the other side of the spectrum, and when I mix those two together, they will neutralize into pure water. So it's kind of neat to do that. So yeah, well, that's kind of another thing to kind of mention there. What do you guys notice about milk? Where did milk register?
Kind of acidy, but in the middle.
Yeah, slightly acidic. What about tomato juice?
Kind of acidic. It's kind of.
Yeah, it actually has a very strong acid to it, that's actually one of the reasons why the home remedy for skunk smell is to throw basically take a tomato bath. That's the same reason because of the acids. Someone said, "What's citric acid?" It's the same stuff in lemon juice. You ever screwed yourself in the eye with lemon?
Yeah.
Yeah, it's not something you want to do over and over. Okay. That substance that we had in the back of the class, the citric acid, is actually pure citric acid. So it's not like, with the natural stuff like out of your fruits and stuff, not really going to be as strong, but the citric acid is going to be really, really strong. That's why I want to make sure we have our safety glasses on. All right, any other questions on pH? It's just kind of neat, something to do. All right, got something, move it around. All right, now some of you guys somewhat discussed this yesterday when you work on the homework, but the difference between a mixture and a solution. The difference between a mixture and a solution. Do their best to describe this. What's the difference between a mixture and a solution? Yes.
Like a mixture, like they're together, but they're like separate.
Together but separate. What is this, 1960? Together but separate. What?
A mixture is like trail mix, and then a
Yes.
solution has a chocolate milk
Gatorade, Kool-Aid.
or like coffee.
Kool-Aid. I go more with the Kool-Aid than the chocolate milk. Okay. So the mixture is perfect. A mixture, we tend to think of solid mixtures. That's going to be something like trail mix. When you have a solid mixture, you can easily separate them if you had to with your hands. We can also have a liquid mixture. That would be like basically what I have over here. This is a liquid mixture. I take this up, everything's mixed together, and then over time it kind of separates. Do the same thing with water. Take water and oil, that's a liquid mixture. You can mix them up and then they'll separate themselves out due to density. So that's basically, you can have liquid mixtures as well. A solution, it has to have dissolved. It has to be completely dissolved materials. For example, to make the citric acid, I had to take the citric acid in powdered form and put it into water And then by stirring it, I now have citric acid solution. Okay, so that's your solution. You're going to have dissolved materials. Now let me tell you some other things that are kind of interesting to talk about with solutions.
They're compound.
So
They're compound.
they're not really compounds.
They're not a compound.
What did I do with that? It's gonna make me really mad now that I can find it. All right. Well, I was gonna talk about something now I can't find it. We'll talk about that later. Okay. So, any questions on solution versus mixture? And mixture again, we can separate them out. They're keeping their properties. With a solution, it's completely dissolved within a liquid. So basically, there's two differences.